Friends, welcome to Ascent School of Science e-learning platform. I am educator Santosh Kumar. Today I am going to teach 12th mathematics indefinite integration of lecture 6. So let us start. Today we are going to discuss some formulas which will be useful in entire integration chapter. So the first formula we are going to study is, see, already we have discussed some basic formulas in my direct video lecture, so which I was taught on the board. So here I am going to give complete explanation of some formulas. So first formula is d by integration of 1 upon a square plus x square dx. This formula is 1 upon a into tan inverse x upon a plus c. So how we are going to prove this? See, here I am taking x square a square common from the denominator. So what you are going to get? 1 upon a square into 1 plus. Here from this term if I take a square common, it becomes 1. Here there is no a square. So while you are taking common a square, you will get x square upon a square. Or take this a square outside. So this can be written as x plus a whole square. Now x by a is equal to t I am taking. So what you are going to get? Differentiate. So x derivative is 1 upon a into dx is equal to dt. So dx can be written as a dt. So now replace it. So 1 by a square into a dt upon 1 plus t square. 1a will get cancelled. 1 upon a. Already we have studied integral 1 upon 1 plus t square, that is tan inverse t. Now replace the value of t with x by a. So 1 upon a tan inverse x by a plus c. Now this is second theorem. Integral 1 upon a square minus x square. So this integration formula we will use so many times. So 1 upon 2a into log a plus x upon a minus x plus c. Now see, we are going to find the derivative of this, means proof of this formula. See here. So what I am going to get is I am factorize this a square minus x square. So you will get a plus x into a minus x. After that, in the numerator, so always I am going to tell like this is, so whenever polynomial is given in the denominator, try to get numerator in terms of denominator. See, in the numerator there is no x term, only constant. If I add these two terms, so x will get cancelled, only 2a will be left. If I multiply with 2a, and again you are going to get 1. So what I am doing is I am adding and adding these two terms in the numerator. So x will get cancelled, a plus a, 2a you will get, that 2a and here 1 by 2a, so is get cancelled. So you will get this term. So actually this process is called partial fractions. This process is called partial fractions. So using partial fractions you can easily find out this. Now so 1 upon 2a into see here, so 1 upon a plus x plus 1 upon a minus x. If you split these terms like a plus x upon a plus x into a minus x, a plus x will get cancelled, and a minus x upon a plus x into a minus x, a minus will get cancelled. So you will get two terms like this. Here it is a linear polynomial, this can be considered as x. So 1 upon x integration is log x. Here also 1 upon x integration is log x. But after finding integration, you should divide with the derivative of this entire function. We have studied integration of f of ax plus b, that is capital F of x upon a. So means after finding integration, you should differentiate, means you should divide with the derivative of this function. See here, integration of this function is log a plus x. Integration of this function is log a minus x divided by minus 1. We should multiply or divide with divide with minus 1. So you get minus sign between these two terms. Log m minus log n will be log m upon n. So according to that you will get 1 upon 2a into log a plus x upon a minus x plus c. In the same way, the third formula, same to same, just interchange the terms in the denominator. Instead of a square minus x square, you will get x square minus a square. Same procedure, everything is same. Here, what you are going to multiply with the previous formula, just with minus sign. So, in previously you got log a plus x upon a minus x. Here also you will get the same, but with reciprocal of that, because if minus log a becomes log a inverse. See, same procedure, same numerators are also get added, and a plus x, a minus will get cancelled. See, same procedure. See, here a plus x upon x plus a into x minus a, you will get a plus x get cancelled, 1 upon x minus a. Here I am taking minus common, you will get minus x minus a. So by x minus a will get cancelled, 1 upon x plus a, but already here minus sign directly you will get. So 1 upon x, integration is log x, minus 1 upon x plus a is also log x. So what you will get? So log m minus log n, same formula, log x minus a upon x plus a. In previous formula, we got 1 upon 2a into log a plus x upon a minus x. Here you will get x minus a upon x plus a. So one more formula. 1 upon under root a square plus x square. So actually hyperbolic trigonometric function, these formulas are not included in board syllabus or JEE main syllabus. Previously this was in JEE main syllabus, now this was deleted, but anyway you learn the formula, it will be useful. So this integration will be equal to logarithm of x plus under root of a square plus x square. See, whenever you will get a square plus x square, so we have studied the some substitutions. What substitutions we are going to get using trigonometric identities? Just recall the trigonometric identities. So first identity is sin square theta plus cos square theta is equal to 1. Yeah, sin square theta is equal to 1 minus cos square theta. So wherever you will get x square minus a square minus x square, you are going to take substitution as x is equal to a cos theta. So for this directly I am telling. So here a square plus x square. Second identity, secant square minus tan square theta is equal to 1. Secant square is equal to 1 plus tan square theta. So means 1 plus x square or a plus a square plus x square means x is equal to, you are going to take tan substitution. So see here. See, take a square common, after that x by a you will get. So in previous formula we have done like this. Now you are going to take a substitution, x is equal to a tan theta. Now differentiate. So dx is equal to d, what you are going to get, a into tan theta derivative is secant square theta d theta. Now replace all these values. See here, here sec theta can be written as 1 plus tan square theta, under root 1 plus, what is tan square theta value? X upon a. So x square upon a square. So this is 1 upon a. If you take LCM, 1 upon a into under root of a square plus x square. Why I am writing this means, in the answer you are going to replace this value. Now see, 1 upon a into under root 1 upon under root 1 plus x square by a square, x by a value will become tan theta. So 1 plus tan square theta into a sec square theta. Now 1 plus tan square theta under root will be sec theta. So 1 sec theta will get cancelled, and a also will get cancelled. So here you are going to get only secant theta. Integration of secant theta, already we have studied the formula, log of sec theta plus tan theta plus c. Now I am going to replace the value of sec theta and tan theta. So what is sec theta value? Here already we derived sec theta value under root of a square plus x square by a. Tan theta value is x by a. So replace this value. So both having same denominator, log m upon n. So you can write it as log m minus log n. See here, minus log a you will get. So this minus log a plus c, I am going to replace with another constant capital C. So there is no difference if you change the constant also. So but here for the recognition of these terms, so minus log a plus c, this entire constant is taken as plus c. So directly you can apply this question if comes like integration of under root of a square plus x square. So directly you can use this formula, log x plus under root of a square plus x square. Don't bother about this log a. So plus c you can write directly. Now let us see one more formula. Same, integral under root of a square minus x square. If in place of a square, if you have 1, directly the formula becomes sin inverse x. But here a square is given, so take a square common. A square common, so it will come outside. Now see, 1 upon 1 minus x square, that is sin inverse x. So sin inverse x by a you will get. But in place of x we have x by a, so we should differentiate, we should divide with the differentiation of x by a. So if I divide with the differentiation of x by a, that is divide with 1 by a, this a will get cancelled, sin inverse x by a plus c. Now third question, another formula. 1 upon under root of x square minus a square. So previously we have studied x square plus a square. So now we are going to study x square minus a square. Same substitution here also, actually cos h inverse x by a. So this formula is not included in any one of the syllabus previously, but it was in the syllabus. So anyway, now let us see the derivation of this. Now what I am going to take the substitution, previous one, see here, x square minus a square. If you recall the trigonometric identities, like secant square theta minus 1 is equal to tan square theta. So here it is in the form of secant square theta minus 1. So x value you are going to take a secant theta. So see, x value I am taking a sec theta. So differentiate, dx is equal to a into sec theta, derivative is sec theta into tan theta d theta. Replace this all, integral dx replaced by a sec theta tan theta d theta into under root divided by under root. Now x square value is a square secant square theta minus a square. So take a square common, it will come outside and it becomes a secant square theta minus 1 under root is tan theta. So now a get cancelled, tan theta get cancelled, again integration of secant theta. Now so integration of secant theta is log of secant theta plus tan theta. Here from this secant theta value x by a, tan theta value will be under root of a sec square theta minus 1, like this. Okay, secant square theta minus 1. Now replace the values, x by a sec theta value x by a, tan here sec theta value again x by a, take LCM. So log x plus under root of x square minus a square upon a, that becomes minus log a plus c. So this entire term is taken as capital C. Okay, now so integration of this one plus log c, here c value is taken as log c, here c minus log a. Now here, so according to same steps, so integration of 1 upon x into under root of x square minus a square, this can be written as 1 upon a into sec inverse x by a. Instead of a square, if you have 1, directly you will get the formula. Same procedure we are going to use. Now we are going to study another important formula, that is integration by parts. What is mean by parts? In the integration, if there are two functions, in the product, so how you are going to integrate? So let us consider u comma v are two functions, and integration of u into v dx, if you are going to find, like simple example, x into sin x, for example x into sin x is given. So how you are going to integrate this? So here the formula is given by u into integration of v dx minus integration of du by dx into integration v dx whole dx. This formula you need to remember, and proof of this formula is also there, but we are not going to derive this. Just remember this formula, u into v whole dx. In NCERT textbook clearly they have given the proof. So just go through, within 3 to 4 steps you are going to understand. So that is very easy. Each and every formula in the integration is the reverse process of derivative. So if you take the reverse process of derivative, you are going to get this formula. Now here two functions are given. So which function is taken as u and which function is taken as v? See, if we observe entire formula, everywhere integration of v dx, integration of v dx. So in short, out of these two formulas, which function is easily integrable? For example, log x integration we don't have, so log x cannot be taken as v. So whatever the function is easily integrable, that function we should take it as v. And some more, for some more clarity, so we are going to use this term ilate, ilate, ilate. So I refers inverse trigonometric, L refers logarithmic, A refers algebraic, T refers trigonometric, E refers exponential functions. So according to this order, whichever the function comes first, that should be taken as U. Whichever the function comes first. For example, they have given two functions, one is trigonometric function, one is logarithmic function. So according to this order, logarithm comes first and a trigonometric function comes later. So logarithmic function taken as U, trigonometric function taken as V. And so if there is only one function which is not integrable, like only log x, integration of log x is given, so for that there is no second function. In that case, you need to take 1 as the second function. 1 as the second function, 1 can be taken as v. Now, see, here why I am going to learn these formulas? To prove two formulas. Further two formulas we are going to apply integration by parts. Now see, integration of under root of a square plus x square dx. This formula is x by 2 into under root of a square plus x square plus a square by 2 into log x plus under root of a square plus x square plus c. Let us start the proof of this formula. See, here x is equal to a tan theta we have taken. So differentiate dx is equal to a sec square theta d theta. Now replace in this function. So a square plus a square tan square theta into dx के जगह पे a sec square theta d theta. From this a square comes outside, that becomes a into 1 plus tan square theta becomes sec square theta, under root of sec square theta becomes sec theta. So finally you will get a into a square into under root of secant cube theta. So take this as equation 1 because we are going to furtherly use. So this integration I have taken as I. So I is equal to a square into integration of secant cube theta d theta. This secant cube theta I am splitting into sec theta into secant square theta. Now this function I am taking as u, this function I am taking as v. See, integration of sec theta also you know, integration of sec square theta also you know. But among these two, integration of secant square theta will be simply tan x. Integration of sec theta will be log of sec theta plus tan theta. Furtherly you are going to face the difficulties. So for that, because logarithmic function is getting and compound function you are getting, so that's why a simple integration you will get, integration of secant square theta is tan theta. So now see, uv formula is u into integration of v minus integration of d by du by dx, yeah, du by d theta into integration of v whole dv. Now integration of secant square theta, that is tan theta. Now I am multiplying with this a square into integration of sec theta, differentiation is sec theta into tan theta. Here integration of sec square theta is tan theta. So finally you are going to get is sec theta into tan square theta. Now here a square into sec theta tan theta, first term I am keeping as it is, minus a square into tan square theta I am writing as secant square theta minus 1. Again multiply with this. So you will get a square into secant cube theta d theta plus a square, because minus into minus become plus a square into sec theta. Now see, this a cube secant cube theta, in previous one, see here I value is a cube secant cube theta. So here this value is replaced by I. So this minus I. So if I take this minus I to the left side, I plus I become 2I. So here a square sec theta. Sec theta integration you know, log of sec theta plus tan theta. Now replace all the values. So I is equal to a square upon 2 into tan theta as it is, sec theta I am writing as under root 1 plus tan square theta plus a square upon 2 into log mod sec theta plus tan theta can be tan theta plus sec theta can be written as 1 plus tan square theta plus c. Now what is the value of tan theta? X by a we have taken, so that value you replace and simplify. You will get I value as x into under root of a square plus x square by 2 plus a square by 2 into logarithm of this. So here some more constant minus log a you will get, that is included in constant. Okay, so you need to remember this formula. In the similar way, we are going to derive one more formula under root of a square minus x square. So x value you are going to take sin theta, a sin theta. See here same procedure, x is equal to I am taking a sin theta, so differentiate dx is equal to a cos theta d theta, replace the values. So here a square into cos square theta, cos square theta can be written as 1 plus cos 2 t by 2 dt. So a square upon 2 into integration of 1, that is dt, plus integration of cos 2t dt. So here a square by 2, this integration of 1 will be t, cos 2t integration is sin 2t upon 2. Now a square by 2 into t into sin 2t can be written as 2 sin t cos t, 2 get cancelled, sin t cos t. So what is t value? From this replace t is equal to sin inverse x by a, because sin inverse x by a plus sin t will be x by a and cos t will be under root of a square minus x square by a. So see here a square by 2 into sin inverse x by a plus here a square will get cancelled, x by 2 into under root of a square minus x square plus c. Here the substitutions I have written. So next, here one more formula under root of a square x square minus a square. So here x is equal to what we are going to take, sec theta, secant square theta minus 1 is tan theta. So see here x is equal to a sec theta, dx is equal to a sec theta into tan theta d theta. Now replace all the values, integration of, in place of x, a square sec square theta minus a square into, in place of dx, a sec theta tan theta d theta. Now if you take a square common and secant square theta minus 1 become tan square theta into a sec theta tan theta as it is. If you multiply this, a square tan square theta sec theta d theta, take this as equation 1. Now integration of a square, this tan square I am writing as secant square theta minus 1 into sec theta. See here secant square theta into sec theta d theta minus a square into sec theta, integration of sec theta log of sec theta plus tan theta, and here uv formula I applied here, uv formula. Okay, so is equal to a square into sec theta into v I am taking as secant square theta. So same, so u into integration of v dx minus integration of du by dx into integral v dx whole dx, and minus this term was not written here, this term should come over here. Now a square into sec theta and integration of secant square theta is tan theta minus integration of d by d theta of sec theta can be written as sec theta tan theta, and integration of secant square theta is tan theta minus that second term as it is. Now here this term can be converted into, see here multiply with a square into sec theta tan theta minus a square into tan square theta into sec theta. From previous slide this value, see here from equation 1 I can be written as integration of a square tan square theta into sec theta d theta. So this entire value is replaced with I, so minus I. So if I take this I this side, so it becomes 2I is equal to a square sec theta into under root of sec square theta minus 1, that is tan theta, minus a square into log of this. So here I value, and replace sec theta as x by a, x by a, everywhere sec theta can be written as x by a. Now simplify, x is equal to, sorry, I is equal to what you will get, x by a into under root of x square minus a square minus a square by 2 into log mod x plus under root of x square minus a square, divided by log a should be there, that is plus it is converted into plus a because minus sign was there. So this entire constant whatever you will get, that is taken as c. Okay, thank you students. Please remember these formulas. Proofs does not important to the board examination, but all formulas are important to the board examination. Thank you students.